Hello friends, and welcome to another lecture from Architects Academy Virtual Classroom. Today's subject is going to be partly glazed and partly paneled partition construction. So what we have here is a room which is of a dimension of 3.85 meters by 6 meters, and we are to provide a partition in the center of this room somewhere. So this is a partition which is of a total length of 3.85 meters. So looking at the same room in perspective, what we are seeing is a room, and in between the room we are seeing this partition. Now let us try to just take down these walls so that we'll be able to see much more in detail about the partition. So as you can see here, the partition is consisting of a timber frame which you can see on the outside, and there are infill panels at the top and at the bottom, and in between there are glazed panels, and there is a door in the partition. So now let us see much more in detail about this partition, how it is constructed, and what is the type of joinery that is used. So if we look at the partition in detail, we'll see that the total distance of 3.85 meters, which is seen here, has been divided into parts, like each part is 900 mm wide panels, and then there is the framing which is there, the framing which is of a size of 50 by 75. You'll see that the partition has also been divided into parts, like for example, we'll see that this is the total height is 2.1 meters up to the lintel level, and then 0.75 meters above the lintel level. We'll also see that the panel continues up to a height equal to the sill level, which is about again 900 millimeters from the floor level. So let us look at this partition more now in detail. So what you're seeing here is members of the frame. So what you will see is that there is a top member which I have highlighted here, then a bottom member which I have highlighted here, and there are two vertical members, one on this side and one on the other side. There are also intermediate vertical members which you can see here, which are being highlighted right now, and then there are the horizontal members at the lintel level, at the sill level, and at the bottom level. So this is forming the frame of the partition, and in between the frame of the partition you can see that at the bottom there are three panels which are made out of plywood. In between there are three panels which are made out of glass, and again at the top there are four panels which are made out of plywood. And in one of these panels you will see that there is a door leading to the other side or the other room. Now let us look at the joinery of this partition. So if we go on to the lowermost part of this partition, and if we pull it out, what you will see is that it consists of a member which has been provided with a notch at the location of each vertical member, as you can see, and also at the end, which you can see here, and also another notch which you can see here at the end. So this notch is made in such a way that it is equal to half the width of this dimension of the frame, that it is half of 75 mm. This is 75 mm by 50 mm. This is the size of the frame. Now correspondingly, similar notch has been made in the vertical. So if we take out the vertical from here and look at it, what we'll see is that the vertical also has got a notch which is corresponding to the notch in the horizontal member. So when these two are joined together, we'll see that this surface and this surface will come in exact alignment, and the surface at the back side here and this surface, they will also come in exact alignment. So let us try to move this now into position so that we'll understand how this is joined. So this is how the two members are going to get joined, and when you look at it from a different angle, you will see that this is a joint which has been made between the vertical and the horizontal member. This we call as the cross half joint or cross lap joint. Looking at the same in X-ray view, what you are going to see is that you will see the joint from inside, how the vertical member fits into the horizontal member. So as I said again, this is called as the cross lap joint. Now let us see how the central member here has been joined to the verticals. So if we just pull out this particular member, you will see that this member is also having a similar type of joint which we are seeing here. So a similar type of cross halving is made in this member, with a corresponding cross halving made in the central member. So if we try to pull this out and see the joint, what we'll be seeing is again a similar type of joint seen here. So now this member is going to get fitted into this member to create what is called as a cross lap joint. Let us try to do that again by putting this member, by just taking this member and moving it. So this is how the member is going to get fitted into each other. If we look at it again in X-ray view, we'll see that these two members are joined to each other by using the cross lap joint. Now let us look at the member at the lintel level. So what we'll see if we pull out this member at the lintel level is that this has slightly a different type of joint than the other members. So if we zoom into this and see it, we'll see that this particular member has got a mortise placed in positions where the vertical members of the upper part of the frame are going to come and fit. So this type of a joint is called as a tenon mortise joint, and you will see that these mortises are placed at every location corresponding to the verticals which we are going to get here. So this is what we call as the mortise tenon joint. So if we now take out a member from this particular piece here, and if we try to take it out here, and if we try to see it from the side, what you're going to see is going to be the tenon which is going to be made in this particular vertical member, and it is going to get fitted into this particular mortise. So as you can see, if I just simply move this member here into this, what we'll see is a tenon mortise joint. Looking at it from the X-ray view again, what we will see is how this gets fitted into each other. So what we are seeing is the two members joined to each other. You can view it from different angles to see how this tenon mortise joint is formed. Now let us see how the panels are fixed into the framework. So if we go to this particular panel, what you will see as this panel is made out of a plywood which is 18 mm thick plywood, and it is fixed to the frame by means of beading. So if we zoom into this and look at this particular beading, you will see that it is made out of beading which is having a mitered joint here. So if we try to just see this, separate these two members of the beading, what we'll see is that this particular member has got a mitered joint, as you can see here, and this particular member also has got a mitered joint. So these two members are going to get fitted into each other. Now I'll try to fit that here so that you will understand what is the miter joint. So in a similar way, you will see that the panel is getting fixed into this particular timber frame by the use of the beading. Now in similar way as we fix the panel, we are also going to fix the glass. So if we look at the glass, this is the glass pane, and this glass pane is also fixed by means of this type of a beading, again with the help of the miter joint, as you can see. Now let us look at how the door is made. You can see that within this particular frame we have another frame which has been made for the door. So if we try to pull this out, what you will see is that this is a frame which has been made by using two pieces of timber. So as you can see here, there is one piece nailed to the other piece here to form what we call as a ribet. So this is one timber piece and another timber piece which has been nailed onto the first to form a ribet within which this door is going to fit. So if you look at the door itself, what you can see is that the door, if we take out the door from this particular partition and look at it, you will see that the door is made out of a timber frame. It consists of a horizontal member which we call as the rail, top rail, which is of a dimension of 150 and a thickness of 38. The lower portion is a bottom rail which is made out of again a member which is 150 in height and 38 mm thick, and then the two side members which we call as the stiles. So these stiles are going to be 100 mm by 38 mm again. So this is how the door is made. It is fixed to this particular framework or particular inner frame by means of minimum 3 hinges, butt hinges, and then there are going to be other type of hardware like the handle, the door stopper, and the hydraulic door closer. Now this hydraulic door closer is just a very schematic sketch which has been shown here. So part of it will be fitted on this door and part will fit on the frame. The hydraulic door closer will allow the door to automatically close once it is opened. So I hope this clears up the question on how to construct a partly paneled, partly glazed partition. If you have any queries, write to us on the email ID shown at the end of this lecture. Thank you.